Okay, so to find the length or the magnitude of a vector, it's just going to be basically the Pythagorean theorem. So it's going to be the square root of a squared plus b squared. All right, and then to find the direction angle, we're going to actually use that same formula we did when we were doing the polar coordinates to find the angle. And so you use the formula that the tangent of, oh, that's not the right thing. I'm sorry. The direction angle is the angle counterclockwise from the positive x-axis. And that's the way we've always done angles. The only time an angle hasn't been that is when we were doing bearings and like you rotated from the south or you rotated from the north. But these are going to be just like normal angles rotating from the positive x-axis. And to find those angles, we are going to use that same formula from the polar coordinates that the tangent of theta is equal to b over a. We said y over x when we were doing it then, but it's basically the same thing. Now, one thing that is slightly different is that the direction angle is going to be in degrees. So let's talk about the hand trick for degrees. All right, obviously, 0 radians, 0 degrees are the same. All right, so as we go up, what's the next angle? Finger. 30 degrees. 45. Good. Okay. What are the quadrant angles in degrees? The quadrant angles? 90. Yeah. Good. I feel like you guys understand degrees better than radians, like most people. But the hand trick, we do a lot more with radians than degrees. Okay, so let's start off, and I'm going to draw all these vectors just because I kind of learned visually, and I think a lot of you are the same way. But a vector with these components mean that you're going to go over the square root of 3 and down 1, so it'd be kind of like this. That's the vector we're talking about. Oh, and I didn't say this, but this is the notation for magnitude. So when you see like the double absolute value, that just means the magnitude. So we're going to find the magnitude of this vector. We're going to do the square root of, this is a and this is b. So the square root of 3 squared plus negative 1 squared. All right. So that should just have a magnitude of 2. All right, now theta is going to be that angle right there. So what we know is that the tangent of theta is equal to b over a. And we are not going to simplify that. We're just going to leave it like it is. What does that mean for the hand trick for tangent? One bottom, 3 top. What finger is that for degrees? 30 degrees. Is that angle 30 degrees? No. So we want 30 degrees in quadrant 4. So what angle in this picture is 30 degrees? The reference angle is 30 degrees. That would be that one. And so then what does that make theta? 330. So I think on degrees, you can kind of just logic your way to it. We don't have to do know what 30 degrees is in every quadrant. I think if you draw the picture, you can kind of just see it. but that theta is going to be 330 degrees. All right. Let's look at another one. So for B, it is in linear combination form, but it means the same thing. Our horizontal component is -10, and our vertical component is 10. It's going to be this vector right there. So to find the magnitude, we're just going to do the square root of a squared plus b squared. All right, and then we know the tangent of theta is equal to b over a, or just -1. So what does that mean for the hand trick? Yeah, it's going to have to be the middle finger. So you have to have the same number of bottom and top fingers. So that's 45 degrees. So what that means is this is 45 degrees, the reference angle. So what's theta? Or what would you do to find theta? Right. So that's 135 degrees. Sure. There's one that is on your homework that a lot of people are asking about, so I'm going to go ahead and talk about it. But let's say just some random problem that is in quadrant 3. And we know this is 30 degrees, our reference angle, but we want to know this. What would you do? It'd be 180 plus. A lot of people, because on our examples we subtract it every time, that doesn't mean you subtract every time. So 180 is this much, and then you add 30 more. So that's going to be 210. So don't be surprised if you see one like that. All right, so this last one is going to be super fast. This is why it's kind of important to draw them, because we can do this just by looking at the vector. All right, so I know that my terminal point is at 0, -5. So here's my vector. How long is that vector? 5 units. What's up? What's the direction angle? Yeah. Pretty easy. So if it's a horizontal or vertical vector, don't worry about using the formulas. Just use your common sense. Okay, so now we're about to do the opposite. We are going to know the magnitude and the direction, and we are going to find the vector that has that. All right. So if we have the magnitude and the direction angle, we can find a vector by using this formula. You're going to do the magnitude, and then we'll have the component form. And we're going to multiply that magnitude by the cosine of theta to get the horizontal component, and the sine of theta to get the vertical component. And for those of you that have been here, that should look very similar to what we did with polar form to change. What we did with polar form to change it to rectangular form. So to get x, we did the r cosine of theta. and then the y was r sine of theta. So this is the same thing, but r is kind of translated to the magnitude, which they both are the same thing, the distance from 0. So it's not really a new formula, it just looks a little different. Okay, so what we're going to do on this example is find the component form and linear combination form of the vector that has the given magnitude and direction angle. And again, I'm going to draw it. So this vector is 2 units long and the direction angle is 300 degrees. So what quadrant is that going to put us in? All right, so our formula, we take the magnitude and we multiply it by the cosine of theta and then the sine of theta. Theta in this case, is 300. All right, so we do not have a finger for 300 degrees. Which finger are we going to use? 60. So the reference angle is this one. So if all the way around is 360, that has to be 60. So we use 60-degree finger. Is cosine going to be positive or negative for 300 degrees? Cosine is going to be positive. Okay, so positive 1/2. And then sine is going to be negative square root of 3/2. All right, and then we'll just distribute that too. And there's my vector in component form. All right, and then for linear combination form, we just need to include the I and the J. So it's going to be 1I, or just I, minus the square root of 3J. All right, let's do one more. So this one, what quadrant are we going to be in? 3. So if this is one that we can do with the hand trick, and the angle has a 5 at the end, what angle does it have to be? Yeah. Now we could still do the math and do it. We would, what would we do? We would take 225 and subtract 180 to get the reference angle. All right, so the vector is going to be 7 times the cosine of 225 degrees, comma, sine 225 degrees. Right. In quadrant 3, both of these are going to be negatives. And then we'll use the 45-degree finger and do square root of the top over 2 and square root of the bottom over 2. And then when we multiply by 7, nothing cancels out like the other ones. So it's just going to be kind of a crazy looking fraction. That's the component form. And then linear combination form, we just put in the I and the J. Okay. So if I gave you your papers today, then in that stack is the page from the book. That's page 551. And the assignment is numbers 7 through 14. Now, if you got your paper yesterday, you're going to need to change number 13 and number 14. I went ahead and changed it on the people who hadn't already received it yet. But I made these copies before I looked closely at the problems. So if you had your paper from yesterday, I want you to change number 13 to negative I minus square root of 3j. And then 14, 5i minus 5j.